Okay, so let's go through how to this radioactive dating game. So this is planned for about a 2-day, probably take you 2 days to figure out how old each of these fossils are. So that's your goal, is to use either carbon-14 or uranium-238. You've been kind of seeing how they decay over time, and that set pattern that the graph follows, that the decay follows, is what we use to figure out how old is a fossil or a rock. So you're going to try carbon and uranium for both objects and try to figure out how old are they. So I'm going to walk you through one or two of those to do. So you can see, like, taking snapshots of things, we should be very good at by now. The goal is to figure out the age that each of these is, and I'm going to show you how to do that. When you click on the radioactive dating game, it is this last tab right here. So you're basically collecting data. So for this skull right here, this animal skull, I move this detection device over it, and it's going to tell me what the percentage of the elements are. So it's 98.2% carbon-14, and if I click on uranium, it's 0% uranium. So I can take a snapshot of each of those, but carbon-14 is going to be the useful one. But how old is something with 98% carbon? If I take this little scroll arrow thing, I'm just going to slide until you see the C14, 54.9% would be that many years old, right? If I go to exactly 50%, if I can get exactly 50, it should say 5,700 years old. I've got to get to 98%. So if I go all the way to 98, try to get as close as I can. It is a little tough to get exactly accurate. It's a little frustrating. If you, so it doesn't get accurate exactly every time. So I'm going to need you to get as close as you can. And so this allows you to check. You see how it says T162? I'm going to put in 162 to see if that is the right. And it is. It gives me the smiley face. So I can take a snapshot of this right here. So this is 162 years old. This is actually not a fossil. This is an animal skull. Okay, so you're going to do this for every single object. There's a living tree. There's a distant living tree, so it's just further away. There's a dead tree. Even the house is made from something that used to be alive. Okay, so you can figure out how old is each one of these objects. Now, there's a lot of objects. I'm thinking it's going to take you about 3 periods to get the ages of each of these things. Sometimes you can use carbon-14 dating for anything that used to be alive, and if it's not something that was alive or built with something that was alive, like wood, you can also use the rocks. And so if you use the rocks, that'll help you figure out how old is the fossil that's in the same layer. So why don't we do rock number 1 together? Okay. If I do rock number 1, I think this one's rock number 1, so let me go to that. Yeah, that's rock 1. I know that it's rock 1 right there. There's no carbon in it. So I take my snapshot of this right here, and that doesn't, what that tells me is that it must be pretty old, because carbon-14 works for young objects. So I took my snapshot, and this is, some of this stuff's going to take you some time. Paste your snapshot in there. That's my, carbon-14 is supposed to go right there. So let me put that. I need to get a snapshot of the rock and put it in there. You can do that. So it looks like I'm going to need to use uranium-238, U-238. So all I have to do is switch over to here, and it tells me that there's 97.9% U-238. So that's going to be the magic number. Take the snapshot, bring it over to here. The uranium-238 is 97.9. Now, how old would that be? You got to remember the half-life of uranium is 4.5 billion years old, so I would have about 50% left then. I've got way more than that, so it's not even close to 4.5 billion years, which is good, because the Earth was 4.6 billion years, so there was no fossils back then. But I'm trying to get to that 97.9, so if I get to 97.9, up to be exactly there, taking a minute. Alright. I'm not able to, that's as close as I can kind of get right here. Okay, so what you'll do is, this is how many millions of years old it potentially could be. Check to see if that answer gets you close enough, okay? And then that's going to tell us how old this rock is. Now, can you get the ages for every single thing? No. But if you get the age of a rock that's in the layer as this fossil, that's in the same layer as this, we know that original horizontality, all these rocks are put down in one continuous layer so that all of this purplish color is the same age. So if you can get the age of a rock in the layer, you can get the age of the entire layer and everything that's in it. Okay, so hopefully you can do that for different objects in here. If you have 2 rocks, they might not be 100% the exact same age. You got to try to get as close as you can. But the goal is to figure out the ages of all of these different layers. And then when you do that, these color patterns, you're going to color code your lab in that same color code pattern. So if I zoom out, it would look, like all the layers of the rocks that I see in the game, the data table will match up to that.